Hello, everyone. Yeah, microphone works well. Yep, it's me again, another presentation. This time with my colleague Harry about external compute deployment. We will explain what it is very shortly. Little bit about us. I'm basically from everywhere. I work as a cloud architect at ShapeBlue. I was chief architect of a big service provider built in 2012 a very large CloudStack cloud, 13 data centers all across the world. That's how I got used and learned everything about CloudStack. Then I became a ShapeBlue customer for many years, and then joined ShapeBlue. I think there's enough about me. So, Harry.
Thank you. Hope I'm audible. OK. So myself, Harikrishna. You can call me Harry or Harry, but not the Harry Potter. I work for ShapeBlue and Apache CloudStack. I'm a PMC member and, of course, the committer in Apache CloudStack project. I like this phrase for myself. I am born and brought up in CloudStack because even in my previous companies, Accelerate and Citrix, I used to work mostly on CloudStack. So even I'll continue to do the same in my next presentations as well. And yes, that's my family there. I treat them as my teammates too because we work remotely all over the year, so they know everything, what I'm doing and when our teams are scheduled. Yeah, that's about me.
Well, yep. And the born and raised in CloudStack also shows that you're much younger than I. Yep, I'm older than I look. So first of all, clicker, work please. 1 second, hardware failure. I'll just do here. Yep.
Wait.
1 second, guys.
Let me do it for you.
OK, just leave this here. So first of all, this is going to come on 4/21, but it's already code complete. We wrote this for a customer of ours. They are using it in production. So anyone interested can just build packages with this feature as well. And wait. And yeah, and it's just going to work. So the use case from this customer was that they want to place these very big servers with terabytes of RAM as CKS nodes in CloudStack. The CKS part was explained by my colleague Paul in her presentation yesterday. So who wasn't there can watch the video when it comes available, and then things will tie together better. So to get this working, first we looked at the old baremetal framework in CloudStack, which looked something like this. Quite complex, and it was only implemented for Dell 410 switches. So not really usable anymore for this use case, especially as this customer, they already have a deployment pipeline. And no point reinventing the wheel. There are tools that can do that much better than CloudStack could ever do. So we thought of ways of how to connect CloudStack to their pipeline, and came up with this feature. So first of all, explain what external compute resource is. It's simply that anything that compute that isn't natively controlled by CloudStack. Examples. The biggest one, that was the use case for a customer, baremetal servers, but can be directly an application, a service platform, your switches, your routers, hypervisors, which are not supported by CloudStack, and Shiv's robot. But that one, ask me later. There's a special use case. So anything that computes, which you can get somehow to a CLI, API, in any way. So how does this framework work? The deployment has two components. We have a provisioner script in CloudStack that we decided to do in Bash for the simple reason that we want sysadmins to be able to do it. So you don't need a nice, amazing Java developer like Harry, but a simple architect like me can just go and write Bash like any sysadmin can. And then there's this black box that's external to CloudStack. CloudStack doesn't need to know what it is, but we'll see examples of what that black box is. That's the very, very simplified workflow. CloudStack sends external compute resource information to this bash script. This bash script talks to this black box. Probably not necessary to write black box. That's quite self-evident. And then this black box deploys the external compute resource. So in the case of this customer, a very smart pipeline that deploys bare metal servers. So let's see how to do that bare metal now, this new way of bare metal. In this case, CloudStack passes the basic information needed, offering template, VLAN, can be VXLAN, any segregation method, to this through this provision script that then talks to the API. In this case, this customer, they wrote an API that talks to their pipeline. So then the API talks to the pipeline, passing the same parameters, and the pipeline understands what an offering, what a template is, matches to a type of physical server, and deploys that and configures that in a VLAN. Then CloudStack, in this case, the API queries the MAC address of the server and passes back to CloudStack. CloudStack then injects that in the virtual router. So the virtual router is still the DHCP server, as that bare metal server is in the same VLAN. And then that server can just be added to a CKS cluster. That was a use case, but doesn't need to be exactly that. So give a simple example of what a sysadmin or an architect can do without touching Java. Wrote simple bash script that talks to Proxmox API. CloudStack passes the information needed. In this case, I'm not querying the MAC address. I'm just telling which MAC address to use. And the bash script talks directly to Proxmox API that deploys a VM there, and the virtual router serves the IP address. So that VM looks in CloudStack just like any other VM. You can implement lifecycle, a stop, start, restart, or just deploy. It's up to you that you can do in any way you want. But from a CloudStack perspective, it looks like a VM. It goes to the usage database, is managed by CloudStack. And here, the bash script talks directly to Proxmox API. Did not need that intermediary API, but in many cases you do need it. And this was something else that I tried as well. The CloudStack provisioner script, Bash wouldn't be able to really talk in a nice way to PowerShell, so I wrote a Python API that's the intermediary API that then talks through WinRM to PowerShell, deploys a Hyper-V VM, which is then controlled in CloudStack. So we had no documentation is forever saying that CloudStack supports Hyper-V. Wasn't true, but now it is. And yep, now over to Harry to explain the insides of it.
Yes, thank you, Alex. Okay. Just to reiterate or summarize what Alex has already said, all we are trying to do is integrate an external provisioning system into CloudStack. It can be any external thing. It doesn't have to be even known to the CloudStack also. So to fit this into CloudStack, by the way, I'm not going to discuss or give the details of how I implemented this, because that's more like around 100 files I have touched it. I promise I didn't break anything. Yes, so the first question when I got the requirements is, where shall I have to fit this in CloudStack? Either Zen Server, KVM, VMware, that's what we have the plugins in CloudStack, right? Any quick guesses where I can keep this? I can get the answer from the silence also, because I can't fit it anywhere. Because the Zen Server, KVM, VMware, already they are provisioning systems, and everything is hard-coded into CloudStack because they have their own provisioning APIs or CLIs, commands that we use to provision instances. So that's because CloudStack understands only hypervisors. That has to be in a cluster, and there should be a template, and there should be an offering, and then only we can deploy the instance. And then we thought of why not this external provisioner can be treated as an hypervisor into CloudStack. That's the reason we came with an external hypervisor new plugin along with the existing Zen Server KVM VMware plugins, so that we can add any external hypervisor into CloudStack. It can be Proxmox, it can be Hyper-V, or it can be anything else. And this is generic enough so that, as I said, it doesn't have to be any specific type. It's just the external hypervisor. But then, say suppose if someone wants to add some specific changes to their plugin. So I went a bit deep down, and I made another layer of plugins where I can have these plugins plugged into the cloud's external hypervisor. As a default provisioner, I made this simple external provisioner, which will come by default. In my opinion, does all the job. We don't have to have another plugins. But in some cases, if someone wants to have new global settings in their case that fits their use cases, then they can make a new plugin and attach it to CloudStack. And this is the one Alex is talking about. We will provide two scripts, one provisioner and power operation scripts. This is the only thing operator has to develop to make it part of CloudStack. These are the three methods: prepare, create, and delete. This is as part of provisioning, and there are power operations to just start, stop, and reboot and everything. I'll show you like what I have done to make it work with Proxmox. I just made a small script in this create method. Yes, that's all about theory. Then how it will work in CloudStack. Yes, this is the plugin configuration. As I said, we already have the simple external provisioner comes by default, which is good enough, I think, to integrate anything. And these are the only two scripts operator has to develop to make it work with CloudStack. And this is the location. And by the way, this is there is a PR already out there, so if anyone wants to check it out, please do. And there is one global setting, which is to expect whether we need to expect the MAC address from the external provisioning system or not. Because even though CloudStack wouldn't know what it will do, because it's more of a bash script execution, but at least it has to know whether which MAC address has to be configured in the virtual router. So that when the external provisioning VM comes up, it has to contact the virtual router so that it gets the specific IP and it will be part of CloudStack's network. Yeah, I will go through the very traditional flow of what we do, but only thing that has added is the new type of hypervisor, external. And once we select the external, we'll have to select what provisioner type it is. In this case, it's the default one. If someone wants to add a plugin, we can select that as well. And in that cluster, we'll have to add the host, like any other hypervisor. And actually, these details has nothing to do with CloudStack deployment, because everything will be outsourced to that black box. But the interesting part is this add external details things. Please watch out. This will come in next two to three slides also. What we are doing here is, when we add this host, we will give some provision to add some details so that these details will be passed to that black box. CloudStack doesn't care like what these details are, but it's up to the operator like to decide what these key value pairs, and then it will send it to the black box. For example, in my case, I'll be demoing the Proxmax integration with CloudStack. For that, at least CloudStack will need to know like to which API it has to talk. So that will be also in the bash script only. So all these details will be sent to that bash script that will do the job. Same with the template registration. Even when we have to register the template, we get the option to provide these external provisioning details. For example, this can be the template ID or the template name on the provisioning system. Even here again, CloudStack wouldn't know what it is. It's just the metadata for it. And then comes to the final step of the deploy VM. After selecting the external template, it will choose the external hypervisor, and it will call the bash script. Even here also, we can give that metadata so that it will be passed to the bash script. All we are trying to do is isolate this thing, like isolate CloudStack workflow with the bash script and the black box. Only thing we are doing is the passing that metadata so that operators can do whatever they want to do in that bash script.
And before you get to your demo, just for an example of how flexible and this is, Rohit here was playing with this yesterday, and he built in a way that you go in CloudStack, deploy a VM, and what happens is that a file is written to your file system. So you can really use it to start anything for any actions, but controlled through CloudStack, just like a normal VM.
Okay. And the demo time, the most dangerous part for me. I don't want to get into this situation, but let's see. I wanted to give a live demo. I have the recording too. Let's try it out. So yes, I have the two environments here, the Proxmax environment and the CloudStack environment. I'll be adding this Proxmax environment into CloudStack and make a deploy VM work so that it will provision the instance on the Proxmax environment. As I have already shown you on these slides, first thing we'll need to do is add an external hypervisor and select the external provisioner and give it any name. I have already added two, one for baremetal and one for Proxmax. Inside the Proxmax cluster, we'll have to add a hypervisor. And again, these details, nothing to do with the CloudStack. CloudStack wouldn't care what these details are, so this can be anything. And the interesting details will be come into these external details. As I said, this can be an endpoint URL or an IP address, username, password, API, key, secret key. Let's say we can even treat another CloudStack environment and add it as an endpoint here. Like we can deploy an instance from one management server to a completely different deployment itself. Again, I have already added one hypervisor, just not to break my system during the demo. Same with the templates. As I said, all these details are nothing to do with the CloudStack, but only thing we need to make sure of is the hypervisor and external provisioner, so that it will provision the instance on the particular external provisioner. Here also we will get the external details. Like I said, this can be anything, template name, template ID, that can be identified on the bash script. Let's try the interesting part of deploying the instance. I have selected the Proxmax cluster, and I'm selecting the external template that I have already registered. And this is an isolated network in my CloudStack environment. Here I can add any details, but for now I don't need anything. Let me pray to the demo god. So I just launched the instance. If you can see, I have just used the instance ID 91, adding 1,000 just to identify it properly. So this is the VM which got deployed on the Proxmox. Same happens with any provisioning system. That's what we did for baremetal. Actually, thanks to Kiran, who is our QA team, who has helped us setting up all the demo and make it work. This guy is here. We can do all sort of compute-related operations like stop, start, reboot, and anything. We can hide all the unrelated icons, but we can do all stop, start, destroy, reinstall, and anything that supports, that can be scripted on that bash script, which will work to make it work on the Proxmox environment. Yes, that's about it. Till now, I haven't shown you like what I have done in the script, right? Do we have to go back? Why I can't? Okay, let me. I'm just going to the management server. I'm going into the provisioner script. And this is the create method that I have written just to make it work with the Proxmox. The information that CloudStack passes to the script, I just used it. The endpoint, password I have hard-coded for now. The MAC address and the VLAN that has to be configured. And then execute the Proxmox commands through SSH pass. That's it I have done. And we got the instance here. And if you see the MAC address, so the MAC address on I'm checking on the hardware section for the Proxmox VM. The network device has got the MAC address. This should be from CloudStack MAC address only. Yes, 0056. And the VLAN is specific to the network here. It is 1352. And we have tagged it here with 1352. Yes, that's what we have done. Yes, I'm done with my presentation. If you have any questions, please feel free to.
Nice one.
Thank you.
Thank you, Alex and Hari. Any questions from the audience?
Expected.
First question is, to what extent are all lifecycle and other operations supported? Like, can you open the console from CloudStack to the Proxmox VM?
In theory, that's possible. It will be a quite complex example, but only a few of the lifecycle functions have been implemented so far. Harry, what is there already?
Sorry, I didn't hear that.
Which lifecycle functions?
Currently, stop, start, reboot, and the power operations of the compute resource.
Yep.
So the next obvious question is, what's the roadmap for this feature?
So I was discussing with Rohit on this. Like he has proposed one thing, to have one generic API which can take any action. See, for CloudStack, it wouldn't know like what it will be doing. It's the bash script which has to be operated. So we will introduce a generic API, say suppose do something like maybe example API with action equal to, if you want to take clone that VM, the action will be clone VM. The bash script will get that action clone VM and we can operate it from there. So the idea is to have a generic API which takes any action and we can do it in the bash script.
So any arbitrary function. So yeah, you can implement console in your weekends. Would love it.
Maybe nice idea for a workshop.
My question is, these features can support, for example, to be extended to user data, console proxy, these resources. Is it possible to extend to this, to support this in
So
CloudStack?
the virtual router is there, you deploy the VM in a standard isolated network or VPC tier. So it's being routed, the virtual router is the default gateway of that VM. It can be load balanced, port forwarding, all of that. So in the case of CKS, it needs load balancing, it needs port forwarding, so that is happening with the bare metal server. On the second part,
Console, I don't think we can make it work with console at the moment, but we still have to see what we can do there.
Oh, my question is, for example, in the Proxmox existing cluster, it's possible we ingest the existing VMs and orchestrate this? For example, in Bash, we run a command and get results from Proxmox and ingest these VMs.
yes, you could, in your bash script, in your deploy, not really tell Proxmox to deploy.
Yes.
And then that VM
Ingest the
in
VMs.
Proxmox would end up in CloudStack. You manipulate that with your bash script.
You can hack your bash script. Say, suppose when I have shown you a create method, right? There you don't have to deploy an instance, but you can mock it saying which VM you wanted to inject.
Basically, in the Bash script, we can make anything and
That's the idea, to isolate completely from CloudStack and make whatever you want on the bash script.
okay.
And for example, if you want to add your switches, the create command doesn't really make sense. So instead, in the create method, you just write whatever is needed for your switches to be understood by CloudStack, or any computing resource you have.
My question is, can we add multiple hosts to the external hypervisor or the
Yes,
cluster?
we can add. So what will happen is if you add multiple hypervisors, I mean add host form, right? That's what you're talking about.
Yes.
It's like registering multiple endpoints. So there you'll have to try to make it with the host tags, like to which endpoint you wanted to, you need it for the provisioning, the instance.
Okay, so the provisioner script is for each host, right?
Yes.
Is
right.
for each host.
Yes,
Okay,
yes.
fine, thank you.
Okay, any more questions?
Okay, thank you.
Okay, thanks everyone. Please, another round of applause.